Unit 3 for ELTN 117. In this video, we're going to be going over setting up the Arduino software for the Stemtera board and also wiring our first circuit. So if I launch the Arduino software, sometimes it'll come up and with a message saying that you need to upload the latest version of the software. That's up to you. Probably won't make a lot of difference for our class. But I will make a couple of changes here. So when you have this screen to start with, it automatically adds a setup function and the loop function, which we've discussed already. And we can leave those there, that's fine for now. One of the things I'm going to do though is just change the font size. And this is up to you if you want to change this or not. You can change it, like for example, up to 18. I just want to make it a little bit easier for you to see as you're watching this video. So a couple of things here. I will typically start with a header, as we've discussed in the class a little bit before, and include some important information. So I start with, for example, the program title. In this case, is going to be Unit 3 program number 1. And in the future, for each unit, there will be multiple programming assignments. So you want to make sure you put that on the top. When I'm grading your assignments, it'll be important for me to be able to see that. So some other information here. Actually, I'm going to make this a block comment, and if we do that by having the asterisk / here, or the / asterisk and asterisk / at the end, that'll allow this whole area to be a block here, and I'll make it a little bit more readable. You'll notice that the Arduino programming language automatically puts in an asterisk every time you're putting in a comment. So I'm going to say purpose of program, flash and LED. And the author is myself in this case. And I'll put the date. And there might be some other things that I put on here. For example, I could say the LED is connected to, we'll say pin, digital pin D4 in this example. Okay, so that's just some of the basic information that we'd put into the header. And that's not only for your own benefit to kind of keep track of the name of the program and the information, but anybody else who's looking at it. The comments, again, don't do anything in the program itself, but they're there always when you're opening your program. You'll notice up on the top here it says Sketch September 2nd A. It will by default date your program or name your program with the current date. Now, the next thing that we're going to do is initialize some variables. And as I mentioned, for output variables, we use a variable called, or a type called const and int. And I'm just going to say, call this, for example, green LED equals 4, for example. Now, one of the things you can do, if I'm going to name this program here, I was going to call it Unit 3 program. If you click on this top left button here, and we'll go through a lot of the different menus here, but as you're typing a program, one of the things that's kind of good to do as you go is click on this checkbox on the top left. And you'll see on the bottom it says that Sketch uses a certain number of memory, pretty small amount, 1%. But there are no orange or yellow text marks showing that there's some kind of problem with the code. And I kind of do this as I go just to make sure I don't make a mistake. So for example, if I left off that semicolon and clicked that verify button, you'd see an error message here. Now if you look on the bottom, it's hard to see the error, but if you pull up here, it will show you where that error is. It says it's expecting a comma or a semicolon before void. So in that case, we want to make sure we have our semicolon included. And this is the only variable we'll use in the program at this point. And if I go back and check it, verify it, should work fine. Now, some programmers typically, I'm just going to delete this text here. A traditional C programming method is putting this curly brace, which is showing the beginning and the end of the setup, following setup. And that's fine if you want to do that. That's kind of a traditional way of doing it. I typically will put my curly braces on the left end of the code to left justify it. And to me, that makes it a little bit easier to find out where the beginning and the end is. If you click at the end of one of these curly braces, what's really cool is it'll mark or highlight the beginning. So wherever you're checking to see where your code is, you can kind of keep track, because as we write more and more complex code, we're going to have more and more of these curly braces, and we need to keep track of where we are. Okay, so you can now see that we have the 4 parts of the program. It isn't going to do anything at this point, but we've got the header, we have our variable definition, we have our setup, and the loop. So in the setup, since we're only doing turning on one LED, we only have to define one output. Remember that setup is used to define the inputs and outputs. So by using this keyword pin mode, and I'm going to use the variable green LED, and we're going to define it as an output. So again, what this does is the pin mode is defining what the pin number is as far as whether it's an input or an output. So when you see this text here, green LED, whenever the program compiles, it will substitute the number 4 in there. And what that means here, I'll add a comment, is that we'll say the LED is connected to output D4, just as I have up here in the comments. I don't expect that you comment every line of code. It's not necessary, but just anything that's important to remember. Okay, so that we've defined the pin mode. Now what we're going to do is turn this LED on. And so we can do a command here, digital write, and that's the command used to turn on an output. And we're going to turn on the output green LED, and we're going to turn it on high, H-I-G-H. Now, because the microprocessor runs so fast, you wouldn't even see it flash if we just ran it like this. So we have to have a delay in here. If you remember the delay command, for example, if we have a 500 millisecond delay or half delay, these units are in milliseconds. They're not in seconds, otherwise it'd create a huge delay. Now, if I want to flash the LED, I have to turn it back off after I've turned it on. So I'll use digital write, green LED, comma low. Now, this is very important. If we don't add another delay here, what will happen is the program will loop immediately to the beginning, turn on the LED, wait 500 milliseconds, turn it off, and then immediately go back up. And the time it takes to go from this line to this line is literally microseconds. So in order for us to see the LED turned off, we have to add a delay here. We'll make it the same time, for example. And this is basically the end of our program. Now, typically, when we're writing blocks of code, we want to indent it. It makes it a little bit more readable instead of having everything left justified. So if I highlight that code and right-click with the mouse and click down here, increase indent, it automatically indents a certain amount. And we can check our program to see if we have any mistakes by clicking on the Verify button. And the text comes up white on the bottom. That means that there's no errors, no issues at all. Now, in order to download this to our Stemtera board, we have to go to Tools. Whoops, I got to plug in my board, I guess, first. Okay, I'm going to plug in my Stemtera board here. Now, the cable that we're using that you'll have in your kit, it looks like a typical Android type cell phone charger, USB cable. So I'm going to plug that in the side here, and I will zoom in soon on this board so you'll see how this all works in detail. But there's a plug on the end of it. Plug that in, make sure it's plugged in the right way. And if everything is working, you should have the LED on the bottom that says on should be turned on. Okay, now I will zoom in on this shortly, but I want to first go over some of the important things for actually uploading the program. So I'm going to click on this button up here called Tools, and you'll notice here that it says a couple of things. You have to make sure you've selected the Arduino Genuino Uno. That's the board we're going to be using. If another one is selected, it probably will not work. The second thing is that you will probably see a port here, a USB port that says COM5 Arduino Genuino Uno, and you have to select that. Now, if you're using a laptop, you might see a few different COM ports show up, maybe COM1, for example, and it should have this text. If you do not see this text, you can unplug the USB port, plug it back in, and check to make sure that it's working. Okay, so now we're actually communicating to that board. And now I'm going to switch to full screen here. And we can see our Stemtera board. Now, right now I don't have anything connected, and I'm going to show you how to wire this up in just a little bit here. And I'm going to go through some kind of important tips as far as how we wire it up. But what I'm going to do right now is just upload this program. And to do that, I'm going to click on this button up here on the left corner that says Upload. And this is not just checking the program, this is actually uploading it or downloading it, depending on how you want to say it, to the Stemtera board. Now, if there's a problem, you'll see some text down here on the bottom. If it says it's not connected, something like that. And if you can't see the full message, just pull up the bottom of the screen so you can take a look at it there. Okay, the next thing we're going to do is actually wire up the circuit. And I will be going into a lot more detail on how these circuits are connected and how we hook up multiple devices, probably in a following video. But let me just show you an example of how we hook this up. Now, usually you want to do this with the power disconnected, just to be on the safe side. You'll notice that we're going to be using output 4 here. This is the one that we're writing our 5 volts out from, that pin. And so I'm going to start by just connecting a jumper wire to that pin. So I'm going to plug into pin 4. And I'm going to plug it into a spot over here on the board. Now, in the video that you'll watch this week, we'll go through the details of how a breadboard works. But just to give you an idea, each of these pins in this vertical column here are all connected together. Because LEDs need to have a limited current, they typically use 2 volts to be powered, but the Arduino puts out 5 volts, we need to limit the current and drop some of the voltage. So what I'm going to do is add a resistor between these 2 points here and here. And I believe this is a 330 ohm resistor, a little hard to see the color on there. Now, if you take a look at the LED, okay, one lead is longer than the other, and it's a little hard to see probably here in the video, but there's also one side has a flat on it. So the longer lead is the positive lead, and that's the one that will connect to the data output. And the shorter lead is the one that will connect eventually to ground there. So you can kind of see we've got this circuit going from the wire to the resistor to the LED. But we don't have a complete path of current, so we're going to connect the other side of the LED to ground. I'm going to plug that in there and plug it into this pin here where it says GND, like that. And magically the LED starts to flash. So at this point, I'd like you to try to work through just this exercise of getting this one LED to flash. Now we can change a couple of things in the program. We can change the speed of the LED. You can certainly plug in a different LED color there if you want. But this is just the first step, and I want you to see if you can get up to this point in this lab and get to the point where you can get the LED to flash like this. One of the things that's important is making sure that none of these leads touch each other. If they actually short out, it'll cause a problem. The other common problem, again, is that sometimes people will plug it in, for example, to the number 4 over here instead of the 4 over on this side. You must be using the digital outputs in this case. Okay, so that's the end of this video. In the future videos, we'll be connecting more LEDs.